Okay, guys. So today we're going to be working on
What the heck?
exponents, all right? So
Okay.
I hope you guys were able to get to the worksheet that I put up there. I emailed it to everyone, plus I posted it in Teams, so theoretically you should have been able to do something there, right?
Got it.
So let's go ahead and review what we know about exponents, okay?
Okay. Guys, let me get my pen.
Now there are, if you've got a lot of noise at your place, can you mute yourself so that we don't all hear it and we can hear me? I'm selfish that way. All right, so exponents. So let's review what exponents are first, because I want to make sure we're coming from a common place. Remember that exponents are these little numbers that are up to the right-hand side above. Now, this does not mean 5 times 2. It does mean 5 multiplied 2 times, all right? So let's remember that that's what exponents mean. So if I tell you I have x to the third, it means x times x times x. Yes? We get that, right?
Yes.
Yeah.
Yes.
All right, hold on a sec. Got to get you in the gallery view so that I can ask everyone to give me a thumbs up when I'm asking a question. But it's all good right now, so don't worry about it. Now, so if I tell you that I'm going to multiply x squared times x to the third, it's really easy for us to kind of freak out and go, what the heck do I do there? Maybe I should just multiply the two numbers.
Hey, honey.
But remember that x squared is x times x, and x to the third is going to be x times x times x. Now, if we look at this and think about what we know about exponents, then we know that this is going to be x to the fifth, right? Because 1, 2, 3, 4, 5. Hold on, somebody is calling me. I'm about to say, I can't get in. I don't know who this is. Hello. Well, that was certainly exciting. Sorry about that, guys. Sometimes it's a kid calling in going, I can't get in, help me. So, all right. So, if I show you something like this, x to the fifth divided by x squared, what do you think the answer on this is going to be?
10x.
That's a good guess. I like how you're looking at the numbers. That's not going to be the answer, but
3x.
not 3x. You mean x to the third?
Ooh. X with the 10 on top.
No. Let's look at this. Let's look at what
X to the
this
third.
means.
Oh, x times x times x times x.
And then what goes down here, folks?
X times x.
Times
So
x.
when I have this, what can I do with these x's top and bottom?
Subtract.
I'm not going to subtract. I'm going
No?
to cross cancel them, right?
Oh.
So how many do I have left on top?
3.
So it's going to be x to the third. So what we find out is that when we have, whoa, that was a weird looking x. So when we have something like this, it's really going to be x to the 5 minus 3, which is going to be x squared, because there's an x to the third. So there's 3 x's down here. There's 5 up here. But when we cross cancel them, there's going to be 2 left on top, right? Does that make sense?
Yeah.
Yes.
Now, let's look at another example. So what if I have x squared over x to the fifth? Now, what's that going to look like? Because that's kind of weird, isn't it?
-2.
-2. Not -2, -3 maybe.
Oh,
Let's this. How many x's on top?
2.
2, right? How many on the bottom?
5. Mister, I have heartburn.
So now what do I do?
Cross cancel.
I'm going to cross cancel these x's, and I'm left with 1 over x to the third. Now, remember, because I think we worked with negative exponents too, didn't we? Did we work with the negative exponents in all this year? All right. So this is equal to x to the negative 3. Now you may say, what the heck? X to the negative 3 basically means this is an x to the third that's in the bottom of a fraction. So this literally just means take this, change the sign, and put it under the number 1. All right? So let's take a look at some more of this. So if I told you I had x to the negative 2 over x to the negative 4th. Now, if we were going to solve this, we'd have to look at it and say, well, these are both negatives. So, but the rules are still the same. This is still going to be x to the negative 2 minus a minus 4, right? Remember, that's what we decided our rule was when we were dividing in exponents, right? We subtract the bottom exponent from the top exponent, right? So when I do this, I'm going to get x to the negative 2 plus 4, which is going to be x squared. Now, if we're not sure about this, let's take a look at how we could change this. When I move a term with a negative exponent to the other side of the fraction bar, its sign changes. Now, can you see how this turns out to be x squared now?
I get.
Does that make sense?
Yeah,
Give me a thumbs up if you're like, yeah, that makes sense, and that's like really weird. Is that kind of weird? All right. And so when I do this, I'm going to get x over 2 x's, right? And I cross cancel, and what am I left with? So it still comes out to be the same answer, doesn't it?
Yeah.
Okay. Now I'm gonna put one up here, and I'm gonna ask you to work on it a minute, and then put your responses in the chat so that I know that you get what we're doing. Okay. So look at that one, and then chat to me what it is. Think about what it means. Think about what x to the 6th and x to the 2nd means. Think about how you would expand that so that you could solve the problem if you're not sure how to do it by the rules. Remember, there's the rules, and then there's the understanding underneath them that is better to know than the rule. Because it's easy to forget a rule, but it's kind of hard to forget when you understand something. So let's talk about it. What does x to the 6th actually mean? What does x to the 6th mean? Right, David. Good job, Lily. Nice job, Zeke. So this is x times x times x times x times x times x, right? Isn't that what x to the 6th means? Right? And what does x to the 2nd mean?
X to the 2nd.
It's just 2 x's, right? So what can I do with these x's to get rid of them? I can cross cancel. Good, Esteban.
Yes.
Reading your lips there, bud. Good job. So now how many do I have left on top?
4.
4. So I'm going to have x to the 4th. Now let's go back and see if we can remember the rule, okay? The rule said that when I have x to the 6th over x to the 2nd, I'm going to subtract this exponent from this one. So it's going to be x to the 6 minus 2. Well, what's 6 minus 2 going to be? 4. Kind of cool, huh? So we can see how they came up with that rule and that property so that we could understand how exponents work. Because look at that. It makes perfect sense when you expand it, right? We know about cross-canceling. That's not a problem. We understand that completely. We've done that for, oh my God, like forever, right? And so this makes perfect sense. Now, here comes one of the weird things, all right? Now I am videoing all of this, and I will be posting it on YouTube. So Have no fear if you're not taking notes. If you just want to pay attention, I totally respect that. I know that as a student, I don't take notes. I listen intently, and that's how I learn. And then I hope that I can go back and I might make little tiny notes, but everyone knows how they learn and absorb data best, okay? So what if I said something like this? What would I do with that?
I'm playing Fortnite.
That's like really weird, huh? What would I do with that?
Is X to 16?
What's that?
Is it X to the 8th?
No, it's not x to the 8th. That's a. I like how you're thinking. You
Or
cubed the
16.
2, didn't you? I like that. I like how you're thinking. That's a really neat way to think. Well, let's think about what this actually means. X to the 3rd literally means x times x times x, right?
X to the 5th?
But if I'm cubing x to the 2nd, it literally means this, right? Doesn't it literally mean that? Because it's saying whatever is inside these parentheses, I want you to multiply 3 of those by each other. Well, how many x's do I have here? Don't say 1. Not 1. How many x's are here? What does this number tell you about how many x's are there? There's 2. There's 2 here. There's 2 here. There's 2 here. So in total, there's 6, right? So the rule is when we have this situation, we multiply the 2 exponents. So for example, if I have x to the 6th cubed, I'm going to have x to the 18th because 6 times 3 is 18.
Yeah, we should do that.
That's what I said.
Does that make sense?
Yes.
Give me a thumbs up if you're like, yep, that makes sense. I got that. I need a thumbs up if you get it. All right. If we don't get it, I need some feedback on what is confusing so that I know what I can do to help you.
I said that.
So unmute yourself and say, I don't understand this. Help me. I still don't get what we're doing here, or give me a thumbs up. All right.
I have no idea what's going on. I got the first one, but I don't get this one.
Okay. So thank you, Fiona. I appreciate you being honest. You know how much I always appreciate that when people say I don't get it. Do you understand how the exponents work basically?
Yeah,
That like x to the 3rd is x times x times x. You get that, right?
yeah.
Okay, good. I just want to know where we're at so I can help you from there. So none of these things that I've shown you have made sense?
No, it's just the one, just the parentheses.
Oh, so this
freaking me
last
out.
one here is kind of freaking you out? So
Yeah.
let's look at it again. If I have x to the 3rd in parentheses, right? Doesn't it basically mean that?
Yeah, but
I mean, literally, that's what
I
it
don't-
means,
I don't
right?
see- yeah, I don't see the parentheses holding any purpose though.
Well, in this case, the parentheses don't do any good, right? But I'm just using it as I'm trying to be very literal in what I'm putting down so that I can make sure to make that connection to you, okay?
All right.
Now, if I have x squared to the 3rd, it literally means this then, right? Doesn't it literally mean that?
Yeah.
Okay, so let's go another step. So that means it equals x times x. Doesn't it literally mean that?
Yeah.
Now, do I need any of these parentheses since everything's multiplication?
No.
So it's just going to be x times x times x times x times x times x, which is going to be x to the 6th, right?
Yeah.
Does that make sense now?
Yes.
Yeah.
Good. I appreciate you asking because that's the only way I can make sure we understand is if you guys tell me that you don't get it. Now, give me a thumbs up if you understand how this thing works now. Esteban says yes.
This part,
Mr.
but
Botkin says yes. Mr. Ellis says yes. Fiona, good.
I get
Honey.
this part, but I don't get the negative.
We'll talk about the negatives more in a second. Seth, does that make sense to you, bud? Give me a thumbs up if it makes sense. Bella, is that making sense? Hugh says yeah. Teddy, you got that? You still out there? Teddy!
He's asleep, mister.
Hey, Gavin.
Oh, God. Put the video back up. Oh, thank God. That was going to die there for a minute. He's like the Medusa. He's like the male Medusa. Turn to stone. Okay, let's talk about negative
Hey,
exponents.
honey.
All right. Now, let's talk more about negative exponents. So we've got those three properties. So we understand what happens when we multiply, divide, or raise a power to a power. So we've got the basics. Now let's talk about these negative exponents. Now, let's use 10 as an example because it's so nice and tidy and it makes so much sense, right? So this is 100, this is 1,000, and this is 10,000. Now those are also our place values, aren't they, for our decimal system, right? And then if I have 10 to the first, it's going to be 10, right? And if I have 10 to the 0, that's going to be 1. We have the ones, the tens, the hundreds, the thousands, and the 10,000s, right? That just makes sense, doesn't it? Now, here's the deal, though. When we learn to work with...
Who's making breakfast?
I'm not making breakfast.
It's
Now, remember that when we learned remember, you know, for the longest time, we only knew about these numbers, right? And then about 3rd or 4th grade, they said, well, there's some other numbers, and, well, they're a little strange, but they kind of go this way. And you're like, what are you talking about? So remember, we go from here, and we have 1/10, right? And then we have hundredths, thousandths, 10,000s, right? Correct? We get that?
Yes.
Okay, watch. So I've got x to the 0, x to the -1, x to the first, x squared, x to the third, x to the fourth. What do you suppose is going to be here?
X -2,
X -2.
X -3, and
Uh-huh.
X -4.
So what we're looking at is that the negative exponents are literally decimals. They're smaller than 0. So as I look at this, if I see that I have x to the -2, and the rule tells me that it's really 1 over x squared, well, what's 1 over x squared? 1 over x squared is 1 over 100, which is right here, isn't it?
What kind
Is
of
that kinda-
sorcery is this?
Is that kind of freaky? What's that?
What kind of sorcery is that?
I know, right? Don't you love it when math works? You know, a lot of people just teach the negatives, but I like to teach the place values to see that there's a pattern and a reason for it. Because then it makes sense, doesn't it? You're like, oh, well, okay. I got positive integers here, and I've got negative integers over here. It's just like working with negative and positive numbers, right?
Yeah,
Same
I'm just
idea.
kind of shocked.
I mean, it's, what's that?
I'm just kind of shocked. I'm just staring at the screen.
You know, I've told you all year, math isn't hard, is it?
Oh, I guess.
Not in my
sometimes
class,
it
it's
is.
not. Is math hard in my class?
No.
No, not all.
Sometimes, but
Not
not
at all.
Next
You know,
year,
every time. Not every
next
time.
year if I need help, will you like help
Why
me?
is David doing that? Why does he have that thing?
because he's David. It was funny. I got the information back from the student survey that people did on me, and it was interesting. I got a lower score because it said that they disagreed strongly that my work was too hard. And I'm like, well, did it occur to you that the reason it's not too hard is because like kids understand it? I mean, it doesn't mean the work's easy. It just means that the kids get it, right? I mean, anything that we understand isn't going to be hard, right? It's going to be easy. I mean, that's just
Yeah,
what
it's like-
learning is about. So I kind of chuckled when I saw that, and I thought, I would have had a better rating if I had like made it harder for you guys.
It's like, are your kids not failing your class? The work is too easy. That's
yeah,
why.
if my kids are passing, that must mean I suck as a teacher. It's like, can't it just mean that my
Wait,
kids
Mr.
actually learn stuff and understand after I'm done teaching?
Who's that talking, bro?
Wait, why would they all like put that though if everyone like failed the test? like these past two tests that we
You know, it's so weird. People answer, and there's always one person that answers strongly disagree on everything. It was kind of funny actually. I looked through my results, and on every question except for like one, there was one person that said strongly disagree, and I thought, whatever. You know what? All right. So let's look at what the worksheet looks like. I can't remember if this is the same one I actually gave you or if this is,
I got it.
I don't know if this is the same one or
I
if
got
it's the copy I made. Because I usually give you
I
one
got it,
copy.
No.
Does that look like the worksheet that I sent you guys?
Yes.
Okay, good. All right, so let's look at this first one, shall we?
Okay.
So I've got 4v to the fourth over 5v to the fourth. So what's going to happen with those v to the fourths?
You're gonna times them.
Well, if I have 5 over 5, what would I do?
You would do times.
I could
since
cross
it's
cancel
five.
them, couldn't I?
Yes.
So v to the fourth over v to the fourth is just going to be 1, right?
Yes.
Anything over itself is always 1. It doesn't matter how I can do. Isn't this still 1?
Yeah.
Does it matter what those values are? It's still a number over itself. Anytime we have a number over itself, the answer is always 1, right? A million over a million is 1. Anytime we divide something by itself, we get 1. It doesn't matter if it doesn't even matter if it's something we can't solve. It's still going to be 1. So when we look at this problem, we see that what we're going to have left over here is going to be 4/5. Does that make sense? You see that?
Yes.
Because these two cross cancel each other, don't they? And that's why v to the 0 is 1. Because v to the fourth over v to the fourth is going to be v to the 4 minus 4, right?
Mm-hmm.
That's how come v to the 0 is 1.
Huh.
Lily's head is
That's
exploding now, I
interesting.
think.
I'm just,
Did your head explode on that one, Lily?
yeah.
Aha!
I did a little.
More deep knowledge. All right,
What
now let's
is
look at
this?
this. What's x to the third over x to the second going to be?
1. X1.
X to the first, right?
Yes.
So I'm going to have 7 over x divided by 6. Doesn't that make sense?
Yes.
Because these two cancel out and this becomes a 1, doesn't it?
Yeah.
Let's look at the next one down. What's this one going to be? Number 5. How many x's up? How many x's down? 3 up, 2 down, right? So
Yes.
how many are going to be left? I'm going to have 1 x on top, right?
Yes.
What happens to 4/8?
It becomes a 4.
1.
1 what?
1 second.
1 4.
Or 1/2.
Right?
Wait, what
Because
did you say?
x over 2 is the same thing as 1/2 times x, isn't it? Okay. Let's look at a couple more here. Oh, actually, let's move down to some of the weirder ones, okay? Does that make sense so far? Are we getting this?
Kinda.
Okay. Well, it's all good. Let's look at this one here. Now, I'm multiplying these two numbers together, right? Now, first, I'm going to multiply 5 times 2, and I'm going to put that in front, okay? Because it's multiplication. I can move these things around any way I want. I can group them up. And then I'm going to have x to the third times x squared. Do you see how I could do that by breaking up those numbers? Does that make sense?
Mm-hmm.
Okay, so this is 10. What is x to the third times x squared? And he's busy working.
X to the 6th
No,
or 5th?
fifth,
to the
right?
fifth?
Because there's 3 x's here multiplied by 2 x's here. So
Okay.
it's going to be 10 times x to the
You
fifth.
add.
Yeah?
Yeah.
Okay. All right, pick one for me. Someone pick one for me.
17.
17, okay. So let's look at number 17.
Probably the easiest one.
Now, I have only one coefficient, so I know that my number is going to start with a 2, right? Because that's the only number. I'll do 21 next, Zeke. Now, I've got r to the
Oh, it's
third
not
times r. How many r's am I going to have then?
2.
5.
Remember, this doesn't mean 1 r. What does this mean?
Mister, it looks like 5.
You know, I want to like rub it out, but I think it's just the fact that
I think
it's
there's
a
3.
three,
I think that's
actually.
3.
So 3 plus 1 is,
4.
right? So 2 times r to the fourth. Now remember, I sent you that worksheet with the answer key, right?
Yes.
So whenever you get lost, you can always check the answer key and go, it's what? And then go back and look at it. That's why I like to give you the answers. Okay?
Or if your parents are pressuring you to do your work, otherwise they're going to turn off the Wi-Fi, you can just send them that and say you did that.
Don't your parents go to work though?
No,
Oh,
my
forgot.
dad.
My
yeah.
dad actually is essential. My bad.
I'm essential, but I have to work from home essential. Now, k squared squared. What are we going to do with k squared squared? Well, it literally means, right? And what's k squared times k squared going to be? It's going to be k to the fourth, because we add the exponents, right? Because there's 2 k's here times 2 k's here, right? So that gives us 4 k's over here, right? Let's do one that makes a little less sense. Oh, let's do this one. Let's look at number 23. So this is literally right? So what's my number in front going to be? What's my number in front of the answer going to be?
21p.
No. What is it?
Oh,
Remember, I'm going to
7.
multiply those two numbers together, right? What do I get when I multiply 7 and 7?
49.
I get 49. Now, how many p's are here? Don't say 1. How many
3.
p's are here? 3. Right,
3.
Esteban. How many are here?
3.
When I multiply 3 p's and 3 p's, I get p to the 6th, don't I? Because that means that there are 6 of those items out there, right? So remember, this means I raise this whole thing to the 2nd power. Okay?
Got it.
All right, let's look at some of the, is this all making sense so far?
Kinda.
We doing okay?
Yeah.
Why is he
Okay.
make it?
Oh,
Yes,
how about
sir.
number 16? Number 16.
No, let's do number 49.
40.
I thought we were gonna do 21. JK.
I did 21. So let's look at
Yeah,
this
I know,
one.
Mister. That's why I said.
You're very funny. Now, what am I going to do? What should I do first? Let's multiply those 3 coefficients together, right? 6 times 2 is 12, times 3 is 36, right? Now, how many x's do I have in this problem?
6.
No.
7. You have 7 X's.
7, right? 4, 5, 6, 7.
Oh.
Right? Because 1x means x to the first, right? So I have 4 here, I have 1 here, and I have 2 more here. That gives me 7 total. Yeah? Let's do, let's do number 46 here.
50.
What number is going to be in front there?
35.
35, right? Because 5 times 7 is 35, right? How many x's do I have in that problem?
3.
30.
So I got a couple people say 3. Anyone have a different answer?
4.
I got 1 here, and I have 2 here, so I'm going to have x to the third. Remember, because this is literally 5x times 7 times x, if I expanded it out. So now you can see that there's 3 x's, which is going to give me my x to the third, right? Any questions on this work at all? Anyone have any questions?
No.
Give me a thumbs up right now if you're like, I'm getting this, I'm good. Okay, good. Fiona, you getting this now?
Yep.
I'm still a little lost,
Hey,
but
Kevin, Oliver.
Seth, how about you? You getting it? He logged in, but I haven't heard from him or seen a response. Seth!
Hey,
Bella, are you
Kevin.
getting it?
Where are
Yes,
ya?
thank you.
Hey, honey.
Okay, so I'm going to end here, but here's the deal, guys. I have office hours at 1 o'clock today. So I'll send an email now to both your parents and to you guys, giving you the information on today's 1 o'clock office hours. So if you're still having problems with this, you can log on with me then and we can work whatever you've got questions on, okay? But please make sure to try some of these right after you get off the phone so that you can make sure you understand it and whether or not you'll need to come and talk to me at 1 o'clock to get a better picture on it, okay? All right? If there's no more questions, class is dismissed. If you're good, then you go ahead and skedaddle. If you still have questions, you can hang and I'll answer questions right now.
Okay, bye, mister.
Goodbye.
All right, bye.
bye.
Mister, can I stay for the fun of it?
I've got another meeting that I have to go to shortly after this. So unless it's for questions, I gotta skedaddle.
All right.
Sorry, bud.
It's all right, mister.
All right.
I'll see you later then.
Okay, bye. Any questions then? Does anyone have any questions? I see I got some people that stayed.
I'm still very lost on how to do the questions like 15.
Like 50?
15 and 49. I'm still lost on how to do those kinds.
So remember that when you look at these, okay? Like let's look at number 50 because that's kind of the same way, right?
Yeah.
So first you're gonna deal with the coefficients. So you're gonna deal with the numbers in front, okay? So literally you're gonna say 7 times 8 times 4. That's gonna be the number that's in front of this new term, right? Does that make sense?
Yeah.
Okay. And then I've got 4 p's here, 4 here, and 3 here. Does that make sense?
Yeah.
So that means I'm going to have p to the 11th, right? And so all I have to do is multiply those 3 together, and that's going to be 56 times 4, 224. So it'll be 224 p to the 11th.
That's the answer?
Yeah. You thought it was harder than that, right? You thought there was another step after that or something?
Yeah.
Yeah, and you do that to yourself. I know you do that to yourself. You're like, well, duh, I can see 224p to the 11th, but that's so easy. How can that be the right answer?
Yeah, I overcomplicate things.
That's all right. That's life, you know. At least you're being responsible about it, right?
Yeah.
You're always a hard worker, Fiona.
Yeah, this whole quarantine's got me messed up though.
Oh God, tell me about it.
Ugh. Well, this